Hey guys, welcome back to another video on this series on training an MLLM from scratch. And we're almost to the training part. So in this video, I'll talk about the dataset that we will use for training and the data loader that we have coded up. And that's it. And we'll begin our training loop. So if you remember, in the previous video, we talked about the model, right? So the model was made of a text part, a vision part, and the projector. The way we will do training is we will follow the recipes of MinGPT and the Lava models, where in the first phase of the training, we will keep the vision model and the text model frozen, and we will only train the adapter. And in the second phase, we will train the whole thing. Now, because I'm doing it on a 3090 Ti, I will do the whole training with LoRa just to make it more efficient. But the essential idea is in phase 2, we will do fine tuning across the board. But in phase 1, we will just do fine tuning or training of just the adapter. I think the GPT-4 paper has a nice diagram about it. Let me see if I can pull it. Yeah, so this is the phase 1 of the training where the vision model is frozen. This indicates frozen. The text model is frozen, and only the linear layers are trained. That's the phase 1. And in phase 2, we will apply LoRa to everything across the board, and then just do a fine tuning across the board. Nothing will be frozen in terms of LoRa. Okay, so I have narrowed down the data sets, and the data sets that I will use I will use Cocoa captions for phase 1. So basically, Cocoa is this data set that is used extensively in the image domain for object segmentation, object detection, and so on. And this data set also comes with image captions. So basically, what I have decided to use is the 2017 version of Cocoa, which has about I don't know, some 100 to 200K images and the captions. So let's see if I can explore. I like dogs, so let's see dog images. Yeah, so for example, this is an image of a dog. I know it's segmented, but the original image won't be segmented like this. The original image would be just an image, and then we have few captions of the image. So yeah, so basically we have multiple captions, and I will try to put this together in a form of instruction tuning, where I will give a prompt of, hey, can you generate a caption for this image, and then the image, and then the response, and I'll just randomly pick a response from here. So yeah, so that's the data set that we will use for the projector training. For the full fine-tuning, we don't need a lot of data, so I will use the same data set that MinGPT-4 used, which is based on the Common Captions dataset. And so I will use the small subset that they used, which has a bunch of images and the captions associated to the images. There are like maybe 100, 200 images that they use, and that's what we will use as well. So yeah, so that's the idea in terms of data sets. Now let's quickly switch over to our data loader, like how we code it up. So first of all, I just created a multimodal dataset class. That's a classes from the Torch dataset. Yeah, so Torch dataset. And basically here I define the required methods, the getItem method. Basically, I pass in a list of captions as text and a list of image paths as images, and labels. Labels are just the input texts. And if basically we load the images, we resize them, and we just convert them into NumPy array and return them as a date. So this is the format that Hugging Face will use, the Hugging Face trainer will use. That's why all of this. And then ultimately, so this is the dataset class. What we also want to do is a data loader. So the data loader, what it does is, you should watch my PyTorch video on this. The data loader will batch our data set. So so here it can do shuffling and so on. And so in the data loader, I'll set a batch size, and then I'll create this data loader object, which is an iterator that that will be used for training. Okay, and then I have two helper functions to generate the data sets for my phase 1 and phase 2, or the data loaders for phase 1 and phase 2. I'll just quickly do a walkthrough of the phase 1, and I'll show you in practice. And that is it for this video. Right, so basically, I'll pass in the annotation directory, the image directory, and then I have a bunch of like caption preambles. Hey, can you create a description for this photo? Can you write a caption for this photo? And so on. So once we load in the images and the captions or annotations, the way I would generate the text or the instruction that should be used for training, I will randomly pick a preamble from captions, then my placeholder token image, and this is the result or the response token. I should have called something else. I don't know why I called it instruct. Anyway, and then the output. That's it. And then I create a data loader out of it and return it. Same thing I will do for the second phase 2 data set. That is all. So pretty simple stuff. So let's test it out. So first, I'll load the function for this helper for this phase 1. I pass the annotation file. I pass the image directory. And then because it's an iterator, I'll just try to showcase the first batch. Let's see. So here's the output. So if you see the input text, could you write a caption for this picture? Placeholder 1. This token will be replaced by image embedding in our forward pass, and then this becomes the answer token, and then beyond everything else, the loss will be computed. Same thing. Could you write a caption for this image? And then we have a response. And then the images are NumPy or Torch tensors, which are 2 to 4, 2 to 4 by 3. Now let's see if we can just loop in the iterator. So you see, like we see various preambles, and that is pretty much it. So this data loader, or these data loaders, the two of them, are now ready to be used in our trainer. Now, in the next video, we will write our custom training or custom trainer, because our model is custom. So we'll have to write custom save and load methods that are in line with the trainer. But once we're done, we will start the training. And I think training is going to be relatively quick for this. Yeah, so stay tuned. Thanks for watching. Please like and subscribe. See you guys next time.